Zombie apocalypse.
Okay, now let's try naman no using double integration method to identify the deflection and rotation if a beam has a double overhang. And this topic will be also an eye opener when can we treat the beam as a beam that deflects singularly or with a single curve, or maybe does the beam produces double curvature already. So how do we identify that? So let's get ready to be neurorized. Okay, suppose that we have this beam. No, we have an overhang on the left and we have an overhang on the right side. Okay, so the span is only one since there's only one distance between support and to another support, which is the definition of the span. So we have two overhangs and one span. Now set EI to a constant, meaning the EI is not identified of what particular value, ano? So it can be of any value. So therefore we set it to a constant, meaning it is an automatic prismatic condition, and we need to calculate the following. So slope at point D, slope at point D, deflection at point C, and what's the maximum deflection. Okay. Now, before we start the analogy of this given problem, we need to identify when does the beam is illustrating single curvature and when does the beam is illustrating double curvature. Suppose that we have this beam, okay, okay, for example, so we need to identify how the beam will deflect. So first type of deflection would be like this. Yan. Okay. So meaning there is a single curvature found on the span. Okay? So pag sabi natin single curvature, if I were to draw that on the other side, so pag single curve, isang nature lang yung nagde-deflect sa kanya. Okay? So dito yung single curvature. Kapag double curvature, kahit sa isang span lang, okay, what is happening is just like this. Ikakaroon siya ng dalawang twisting effect. Yan. So, tinitawag nating double curvature. Now, the nature of identifying it is based on this main basis natin is yung tinatawag nating slopes. So, meaning there is a sudden shifting of the slope, no? From, let's say, from second or fourth into first and third. Likewise, kapag ganito may curvature, ganun din ang nangyayari. So, meaning may shifting from first and third, okay, to second or fourth, okay? Second, and this is fourth. Pagka double curvature, ang nangyayari kasi is, dalawa, same lang yung kanilang slope positioning. Kung first and third, so sa isang support dapat, first and third din. So that's the evidence of having a double curve. Okay? If you look at the support's slope, kaya pag-Hessian roller. Oh, likewise here, dalawa din, no, tangent points. Okay? So same lang din yung quadrants. First, the first one is not first and third, sorry. Should be second or fourth. Yan. This is second or fourth. Second or fourth. Yan. Yan. This is fourth. And this is first and third. Okay? And this is another first and third. Okay? So, pag yan na nangyari, meaning they're doing an analysis of a double curvature. So, slope is a main basis. Pangalawa, sa single curve kasi, pag-usapan natin yung deflection is one-sided lang. So, meaning, lahat ng deflection niya, kung pababa, lahat dapat ay pababa on the specific span. Likewise, for single curve, ganun din naman sa negative bending, lahat sila ay dapat deflection ay pataas. While in the double curvature, may portion na pababa, okay? And then may portion na biglang tataas. Okay? Likewise here, nasa taas, bumaba, bigla. Okay? Yan ang nature ng double curve sa isang span. So, nagkakaroon ng shifting ng deflection din. So, dalawang pointers natin, single curve, there's a shifting of the slope from second or fourth up to first and third, vice versa. While the deflection should be consistent on that particular direction. Kung pababa dapat, lahat ay pababa, and downward is, kung pataas, lahat ay dapat pataas. While on double curvature, there is no shifting of the slope. So second or fourth, pati sa kabila support, second or fourth din dapat yung kanyang quadrant location. Pero sa deflection, nagkakaroon ng shifting. May pataas, bigla may bababa, and vice versa. So balik tayo kanina sa beam natin is, what if the other way around? No? What if I mark it on red? It can happen like this. Yan. Okay? Double curve pa yan, no? Single curve pa yan, kahit paano. Also, pwede maging ganito. Tumaas yung isa, okay? And then, tumaas yung isa. Or pa pwede rin naman, yung isa ay bumaba. Parang mark in blue. Yan. Tapos, bumaba. Okay? And do the reverse of the direction. Pwedeng mark in dark red. Pwede naman isa yung bumaba. Okay? Bumaba. Tapos, tumaas. So, those are the illustrations of how the beam will deflect singularly when it comes to curvature. Pero pag double curve kasi, ito potential cases. Tingnan natin kung paano. Pag double curve, pwedeng gumanito, tapos gumanyan. Okay? Okay, pwedeng gumanyan. Or po pwedeng gumanito, tapos gumanyan, and then gumanyan. And you just do the reverse or the mirror effect image. So, pwedeng kabilaan. Or pa pwede naman pag nagdo-double curve kasi ganyan ang usual. But ma-identify naman natin through the definition of the slope and the curve as defined here. Okay? Now, if this is what we call a determinate beam, then we can calculate for the beam reactions. So, vertical reaction BND will be like this using statics. So, we will have the two reactions. So you can calculate using statics by performing sigma moment at D equals 0. You will get reaction at B vertical 141 over 8 kilonewton. And performing EFY or taking moment at B is equals 0, then you will take the value 579 over 8 kilonewton. Now, what's next? Now, ganun pa rin ang procedure natin. So, take the leftmost part, which is point A. So, set that into a 0, 0 coordinate. Then, let that be our Cartesian coordinate system or the origin. So, okay, positive y going up, positive x going to the right. And then, pass the cutting plane on the very last segment, which is EF, with a distance of 0.5 meters, no? Dito, putulin natin. And then, from the 0, 0 coordinate up to the cutting plane, set as a distance of x. Okay? And then, take a look if the loads are touching the cutting plane. If not, just continue and perform the reorientation of the areas wherein kailangan mo magdagdag, no? Na parang i-touches the cutting plane. That's like what we have done in the past video lecture in a simply supported span, no, using double integration method. So, if I were to continue the loading, ito mag-itsura. Yung 0 degree load, magtutuloy-tuloy na siya. Dati hanggang ganyan, pero itutuloy mo na hanggang dito. Okay? While may pataas ka ng load, mark in green na ito. Okay? Pataas na yan yung mark in green. So that we can continue using the IM so that we cannot violate the rule of the principle of the double integration method. Then, we are now ready to set up for the moment equation. And then, yung 40 kilonewton lang hindi may sasama kasi nasa dulo siya ng last segment. So, by simplification already, you will take these values. Okay? Yan. So, 141, all of them are in terms of pointed parentheses. So, 141 over 8x minus 1 plus 579 over 8x minus 9. Then, 5 halves, batang yung 5 halves of x minus 10. Ito yun eh, no? Nag-rotate kasi yan ng clockwise. Okay? Kasi ito yung cutting plane. Okay, tapos this is a distance of x minus remaining distance of 10. Kasi titingnan nyo lang kung ilang distansya nung natitira. Which is 1 plus 2 plus 6 plus 1 meter. So, which is 10 meters. So, therefore, take the centroid of x minus 10 over 2. So, that's why we arrive on 5 halves of x minus 10. Since the value of this coordinate of the 0 degree load is also 5 kilonewton per meter. Okay? So, then we can now continue. So, calculating the said equation by, of course, by integration. But before that, notice that, teka, burahin na muna natin to. Yan. Oops. Yan. Notice that the moment of 1 kilonewton per meter that rotates counterclockwise has a moment arm of x minus c raised to 0. Okay, so kasi ito may 3 meters distance ka eh. Diba, we are aware that the moment is already has a moment arm inside. So why did I multiply x minus 3 but raised to 0? Don't forget that if you raise the value, any equation to an exponent of 0, let's say k raised to 0 is also equal to 1. In statics, no, parang ganito yung konsepto niya for a shorter discussion. Let's say I have two span, separate spans to analyze. Let's say I place a moment here, let's say M, and I place a moment somewhere here, M, with a distance of A on the left and then the same span of L, okay? Now, if you take a moment, both of them on the right cut portion, in statics, it is true that the moment equation, let's say M prime, para hindi tayo malito, both of them has a moment equation of M prime, okay? And then this is also a moment of M prime in statics. Pero when the beam deflects and the beam rotates, it has something to do with the moment arm since it is integrable. So it is obviously that the function x as a function of the independent condition has to do something with respect to the deflection. It doesn't offer that you don't have a moment or a load, it does not deflect. So there is a continuation or continuity of the application of the load since moment is force times distance. Now, if you set this to x, okay, on the cutting plane, so set it on the value of x, of course. So therefore, we can say that m prime times x raised to 0, okay? So while on the other hand, m prime times x minus a, but raised to 0. Again, the sense is not changing. But if you take the first order integral equation out of that, then we can say that if you integrate this, you will get m prime times x, while the other one is m prime times x minus a. Now notice that this is the slope equation, so therefore they are not equal anymore. But for in the first one, they are equal. How much more for a deflection, which is m prime x squared over 2, not equal to the equation of m prime of over 2 x minus a raised to 2. So there's a difference. So therefore, be careful that whenever you're writing the moment equation, you have to include in a moment the rotation, if that is negative since it is counterclockwise, and the moment arm raised to 0. So you have to prepare that. Don't forget that. Since the moment equation, the moment value 1 is not located at the tip of point A, no? Para masabing times x lang. So it should be times x minus 3 but raised to 0. And then do the following. Now, if you integrate it once, it will be like this one, okay? The slope equation, and this is a deflection equation. So progressively integrate it until you reach EIY or EI delta. So therefore, you notice that if x minus raised to 0 is integrated, then 0 plus 1 is 1 over 1. And if you integrate, magiging squared over 2. So there's a difference. Kapag nakalimutan yan, it will become only minus 1. Let's say, ibinuran nyo to. O, minus 1. So pag integrate nyo to, magiging minus ano lang ito? Minus x. Pag integrate nyo to, magiging x squared. So that is wrong. Mag-iiba yung sense kasi ang load mo nandito. Okay? So wala po siya dun sa pinakadulong kaliwa para sabi x lang yung moment arm. I hope it's clear to the listeners, to the viewers, and to the learners that it is important to include the proper moment arm. But if there's a moment, then the moment arm is raised to 0. Now, before we continue, we need to eliminate the arbitrary constant by evaluation. So this time, let us try to eliminate the arbitrary constants by reviewing the support system. Notice that we have supports at B and D. So therefore, their locations are at x is 1 and at x is 9 meters. Okay? So both of them has deflections of 0, while there is a presence of rotation on point B and D since hinge and rollers allows rotation. So in evaluation of C1 and C2 at x is equal to 1 and y is equal to 0. So again, the terms inside the pointed parentheses, when it is negative, so it is an automatic 0. So that's why at x is equal to 1, y is 0, so we cannot accept the equations like what the x minus 1, it is automatic 0, as much as well as x minus 9. Ito rin, x minus 10, x minus 3. Okay? So what only exists is these three equation. Okay? Because 1 minus 10, 1 minus 9, 1 minus 1, and 1 minus 3 are all 0 when we are using the pointed parentheses when the term inside the phrase is 0 or a negative value. So therefore, we'll come up with the first equation. Likewise, we will do that on the second set of equation while as we perform the evaluation on the second support at the roller support at x is 9 and y is 0. The deflection on x is 9 is 0 meters or deflection is 0. So ano mag-activate na lang dito? Most likely x minus 1 will activate, x minus 9 will be 0 since 9 minus 9 is 0. Also 9 minus 10 is 0 in our language, and the rest will be applicable. Ito, pwede ito magamit kasi they will not impose a negative value inside the pointed parentheses. So we will have this set of equation. Now, using algebra, so I'll come up with the values like C1 is negative 179 over 12 kilonewton square meter, and C2 is positive 121 over 8 kilonewton cubic meter. Note their proper units. Already discussed in the discussion of the principle of DIM and on the past video lecture. Now, we try to answer the slope at B and the slope at D. Now, what x is 1, we will call it y prime is theta b. Then, supplying all the necessary, as you just plug in the value of x is 1 to the possible equations that will exist. Again, the x minus 9 is 0, x minus 10 is 0, x minus 3 is 0, and of course, don't forget x minus 1 is 0 if x is 1. So therefore, as you plug the values at x is 1, then you will get negative 63 over 4 kilonewton square meter. So the negative signs again suggests that a quadrant rule, no? Positive, positive, negative, negative for tangent. So therefore, this is the first, this is the second, this is the third, and this is the fourth quadrant. So it is found on the second or fourth quadrant if that is negative. Okay? That's why the slope at B is found at the second or fourth quadrant with 63 over 4 EI. So don't convert this value kasi wala ka namang value ng EI talaga because it is a constant. Dati kasi nagbo-multiply tayo ng 1,000 cube kasi definite na yung in natin in terms of gigapascal, converting to megapascal and I in terms of millimeters to the fourth. So, identify yung unit. Pero pag sabi natin EI is constant, then the units are not identified but held to be true to all lengths, then you just divide it by EI without conversion because you don't know the proper unit of EI on that specific problem. So, the answer would be the constant over EI. Likewise, we will do the same on the slope at D. Plugging in at x is equal to 9 meters, y prime can be achieved as theta d. So notice that in EI y prime, so what will only activate is, ano yung mawawala is, ito x minus 9 is 0, x minus 9 is 0. Okay? And the rest will be activated kasi hindi naman sila negative inside the pointed parenthesis. And then notice you will get EI theta d of negative 770 over 12 kilonewton square meter. Again, the sign negative means a second or a fourth quadrant. Okay? And also, to continue the delta C as being asked by the problem, plugging in at x is equal to 3 using EIY equation. So therefore, what do we get here is we will evaluate this following as 0 since 3 minus 9 is negative, so set it to 0. 3 minus 10 is also 0. And of course, 3 minus 3 is 0. And the rest will be applicable. Okay? So you'll get negative 23 kilonewton per cubic meter. Again, for negative deflection, it means that, you recall, positive y, and then downward is negative y. So it goes down kapag negative. Okay? As simple as that. So therefore, delta C will go down by an amount of 23 over EI. Now, let us try to connect all of this. Notice that in theta B, we got a second or fourth quadrant. Also in theta D, a second or fourth quadrant. And on delta C, it goes down. So by the sense, meaning, it may deflect like this. Kasi kung ano yung positioning ng tangent line, ando naman yung quadrant location, di ba yung tangent line? So therefore, it may behave like this. Ganyan, no? But of course, we don't know that if C is the peak point, but we are certain here that point C will deflect downward. So maybe it will go straight, parang ganito. Okay, will go straight. I'll try to draw clearly the slope at B para mas maintindihan. Ayan. Okay? So, in an exaggerated form, it may deflect like this, then baka kumuntinyo dito. At kaso, do double curve siya dyan. Oops, I'll try to draw this clearly. Medyo dumulas. Okay, gumanyan. Baka dumiretso pa ganun, then gaganon. Ayan, na double curve. So, baka pag kinuntinyo to, baka bumaba ito, at ito, di natin alam kung bumaba or baka tumaas. Okay? Tingnan natin by finding all the deflection positions ng mga pwedeng source ng tips natin o ng tip of the overhang. Now, let us continue. Okay. Now, let us check first the delta maximum. Now, to investigate the delta maximum, it is an automatic candidate, the tip of the overhang, which is, we have two, tip point A and tip letter F, okay? And the span of the beam. As we can see, there's only one span on the beam. So therefore, there are three possible candidates. Delta A, delta F, and a delta max within the span. The span is BD, no? Now, let us evaluate point A as the tip. Now, at x is 0, that is delta at A, no? At y is equal to delta max 1. I use delta max of 1 to denote that it is just only a candidate of maximum deflection. So, meaning, if I'm going to use this equation, this full equation here, EIY equation, noting that we have already C1 and C2 values, so we can say that EIY is just only a value of C2 since all of these phrases will become 0 when we substitute at x is value of 0. Okay? Notice that it is positive, meaning it is going up for slope. So in a rounded value, it is 15.125 EI, or in fraction, that's 121 over 8 EI. So this will be just only a candidate for our maximum deflection. I'll try to compare their decimal value, but it is better to write in terms of fraction. Now, I'm going to investigate now the other tip of the overhang, which is found on letter F. So at x is 10.5, okay? So all of this equation will activate because all of them will give us a positive value inside the pointed parenthesis. So upon application at x is 10.5, you will get a negative 428 over 3, which is a direction of going down for deflection. So delta F, that is our delta max 2 for the meantime, as 428 over 3 EI, or in decimal form, it's 142.667. Now, you notice that delta max 2 is more than delta max 1. So, for the meantime, our candidate, or the best candidate for the maximum deflection is 142.667, or 428 over 3 EI, found on the tip of the overhang at point F, or the overhang on the right side of the beam. But, don't forget that there's a span. So, we need to investigate it further. Okay. So this time, let us try to view how do we analyze it. Now, considering the span of BD, I'll try to make an assumption that my delta maximum, let's say new letter to introduce, G, okay, this is a point within BD, okay. Now, I'll try to place a candidate on BC. So this will be my point of interest, that is my X, no? So that's why if I will use this equation and then trying BC, as of course, you know that it is limited from 1 to 3 meters. Again, the trick of finding deflection maximum is to use the extreme limit, which is 3, then try to substitute inside the phrases for a better understanding when and when not to accept the equation, since if you're not going to accept the equation, then it is as a value of 0, right? Now, 3 minus 1 is positive, so this is a candidate. Okay to? while 3 minus 9 is negative. How much more if x is less than 3 and more than 1? So most likely, this will become 0. Also, this one is 0. You know, the same reason. And 3 minus 3 is 0. How much more if x less than 3? So this is 0. And so on. So therefore, what equations will only activate if you assume BC is this first term and the fifth and the sixth term, which is C1. Okay? So that's how we do it, no? Pagka nagko-compute tayo ng maximum deflection. Therefore, computing that and then revealing all the roots, since this is cubic, the exponent or degree is 3, then you will find out that there are 3 roots. First root and second root are positive, but the third root is not, so therefore we will not accept the third root. But logically, x is limited from 1 to 3, then both of these are not also acceptable. So therefore, all of the roots are not, no. All of the roots are not okay, so meaning does not coincide the given segment. Okay? So how do we deal with this? Now, yung mga nakita natin value na hindi negative at within the span distance, which is the distance from A, okay? The distance of the span is only up to 9 meters. Notice that 3.1674 and 7.7077 coincides to a segment which is found on CD. So therefore, it gives us already a hint that you need to find it on CD, segment CD. So ganyan po umaksyon yung roots na nakukompute natin na kapag mali assumption is binibigyan kanya na ng hint. Ang ano nga lang dito, magtataka na kayo, bakit dalawang root ang nagko-coincide pa sa CD? Ano meaning yan? Ito na yung nagbibigay sa atin ng idea na this may happen as a double curve. Let us find out if this is a true double curve. Tingnan natin ngayon. Okay. Now, I need to determine the true distance of x, no? Yan. So, limited tayo from 3 to 9. So, therefore, using 9, so madadagdagan lang naman ito kasi ito magiging 0 na ito, 0 pa rin yan. At ito yung magkakaroon existence kasi if x is 9, so positive, lalo na kung mababasa rin but mas mataas sa 3. So, this will be always positive. So, therefore, you will check these 3 roots again. So, kung napansin nyo, nadagdagan lang ng minus of x minus 3 because of this situation. So, therefore, again, the first root is negative 0.1551 meters, so we will not accept. But, the 3.1812 meters and the 7.549 are what we call, both of them are accepted. So, they both coincide with 3 and 9. So, therefore, it is an evidence of double curvature. Pag sinabi natin double curvature, dalawang distansya ang umi-exist dun sa limiting distance. Kapag isa lang, meaning it is a single curve. I hope it's clear. Okay? So, another evidence of double curvature. Pero kanina, nagkaroon na tayo na idea na nagkakaroon ng double curvature kasi sa slope pa lang, sa B at sa D. So, yan yung first condition. Second condition, kailangan yung distance of x mo, may dalawang evidences ka na mag-e-exist na yung dalawang value na x ay nasa span pa rin. Okay? So, that's how we calculate it. Now, dahil meron kang dalawang delta maximum sa span, so paghahatiin natin yung delta G, supposedly kung isang point lang yan, into a new letter, delta G1 and delta G2. That's what we're going to do on the next slide. Okay, so at x is 3.1812, y is delta max 3, or I call it delta G1. So, you just plug in to the equation. So, ano yung mga mawawala? So, ito x minus 9 mawawala kasi negative yan. Also, x minus 9 is 0. And the rest will be added. So, meron ka neto, at netong tatlo. Okay? So, those are the places to be calculated. Then you will get negative 23.1973 kilonewton cubic meter. Again, the negative sign suggests it is a downward deflection. So, therefore, delta G1 is delta max 3 is equal to 23.1973 over EI that goes down. Now, if we supply the next x, don't forget, there's another x that is 7.549. So, as we plug in, so ganun pa rin yung setup equation. 0 pa rin yung dalawang nasabi ko kanina. So, you will get positive 40.6895 kilonewton cubic meter. So, what does the positive means? The deflection is upward. So, therefore, delta G is delta max 4. Delta G2, no? Tandaan nyo, delta G2, hinatin ko sa dalawa, yung delta G. So therefore, it is 40.6895 over EI that goes up. Now, it is the right time to select the maximum deflection. Since delta F, if you compare these 4 values, okay, there are 4 to compare, dapat tatlo lang, ano? Naging 4 kasi nagkaroon ng double curve sa span. Okay, so therefore, it is obviously speaking, delta F max, delta F is the delta maximum kasi mas malaki 142.67 sa lahat. So therefore, we will accept as the true maximum deflection is 428 over 3i, it goes down. Kasi all of them are, delta F is more than to the 3 values of delta max candidates. So there should be only one maximum deflection within the span. Okay? Now, what happens to the beam is ganito. I-drawing na natin na kompleto. Okay? So, yan. So, kanina, ang slope natin sa B and D, notice double curve. And then, note that in delta max C ay nandito, no? Kanina, na-compute natin. Tapos, in delta max delta G1 and delta G2, yung delta G1 at X is 3 point something lang, di ba? So, we got 23.973. So, medyo umilalim pa ng konti. So, somewhere here. Parang ganun. Okay? Kasi kanina, ang ating delta C is 23, no? So, mas lumaki pa ng konti, but 0.1973 lang. Okay, delta C is only 23 over EI. But delta G1 is 23.1973. Pero pagdating dun sa pag-double curve niya, tumaas bigla somewhere here. Okay? Ito yung distance na at X is 3 point something, yung kanina. Or the value is said to be for a while, that is, as I calculated earlier, I forget the value, but let me check the value. This is at X is 3.1812. And the other one is at, ito, yan yung at X is 7.549. Okay? Para lang guided tayo. And then at delta A, so tumaas, so somewhere here. And delta F, say, point natin, yan, delta A. And delta F is bumaba, no? Ayan, no? It is bumaba. So, therefore, nandito. So, therefore, ito yung curvature niya. Unahin ko sa span, gumanon, tumuloy pa, tapos nag-double curve pa ganun, then gumanon. Okay? Exaggerated form. Teka, ayusin natin para mas maganda yung reading ng deflection. Sabihin na natin na nandito, medyo exaggerated na lang ito. So, ito, gumanyan. Okay? Tapos ito yung peak point, tapos gumanon. Ayan. Tapos yung A natin, gumanito, no? Ayan, tumaas. So, those are the setup. This is the final elastic curve in exaggerated form. So, parang pag-drawing natin na maayos dito, okay? Parang nagmukha siyang ganito. In exaggerated form, para mas madali makita. Gumanon. Then, gumanyan. Actually, mas mataas yung nasa kanan, ano? Sige, ayusin natin ng konti. So, drawing in violet na lang. So, this one will happen. 115. Tapos, gumanyan. And then, gumanon. And then, gumanyan. Something like that. Okay? So, teka. Ayusin natin. Pangit pala. Okay. Isa na lang. This one. Yan. Yan. So, yan ang final elastic curve. Kasi ito yung pinaka-dual curve niya. Okay. Double curve na nangyari. So, that happens to be when it's subjected for double curvature. And the answer is delta max of 428 over 3 EI going down. So, I hope you learned something new today. Thanks for viewing, and as a tradition, you have been neurorized, and see you in our next video lecture. And coming up next, application of double integration method to indeterminate beams. So, we will start in understanding prop beam, then followed by restrained beam.